Okay, we're going to identify multiple types of transformations, multiple transformations of the quadratic parent function. It says identify the transformations from the graph of the parent function f of x equals x squared to the graph of each function and then graph the function. So we're going to look at the equation and tell what's going to happen to the function that we're going to graph in relation to the original parent function. So the first thing, I'm just going to go from left to right. This 2 is a leading coefficient because it's in front of x squared, so it's a leading coefficient of 2. And for leading coefficients other than 1, if it's greater than 1, it's a vertical stretch. So the first thing I notice about this equation is there is a vertical stretch of 2. Then I notice there's an adding 1. Well, when you add, you go up. So this graph is also going to go up 1. So the vertex is going to not be at 0, 0 this time. Okay, in order to graph this function, you have to find the vertex first. Since there are no parentheses, the x value of the vertex is 0. And then the y value of the vertex is the constant, so that's going to be 1. So 0, 1 is going to be my vertex. So I need to make an xy table with 2 numbers higher than the vertex and 2 numbers lower. So I'm going to put my vertex in the middle. And 2 numbers higher than 0 are 1 and 2, and lower is -1 and -2. Now I'm going to I'm just going to work with the positive values, and I'll talk about that in a moment. I'm going to plug the 1 in for x squared. So I'm going to have 2 times 1 squared plus 1. Well, 1 squared is 1. 2 times 1 is 2, and 2 plus 1 is 3. So we have the point 1, 3. And the reason I said we're not dealing with the negatives is because if you find this, we're going to use symmetry for the parabola, so the 3 would also go above the vertex as well. Okay, now I'm going to plug in the 2. So 2 and 2 squared plus 1. Well, 2 squared, 2 times 2 is 4. 2 times 4 is 8. Plus 1 is 9. So if there's a 9 here because of symmetry, there's also a 9 up here. Okay, now I'm going to go ahead and graph these. Okay, I'm going to count by 2s. You can do that. You just got to tell me on your scale that you're going to count by 2s. Okay, so -2, 9, if I'm counting by 2, that's -2, and then 2, 4, 6, 8. 9 would be here. -1, 3, -1, and then 2, 3 right here. And then 0, 1 is right here. Oops, no, I'm sorry, I'm counting by 2s. It would not do that. Okay, so 0, 1 is actually right here. Sorry about that. 1, 3, if I'm counting by 2s, it would be right here. And then 2, 9 would be right there. Okay, I'm going to make my parabola. Try to make it a U on the bottom and not a V, because if it's a V, it's an absolute value function. Okay, that is the first problem. Second problem. Oops, sorry about that. The second problem, because there's a negative sign in the front, it's going to be reflecting across the x-axis. And then I have parentheses, so this plus 3 means it moves to the left 3 units. Okay, and then that's the end of the equation. So that's all that's going to happen to this in relation to the parent function. So now I got to get the vertex. The vertex is the opposite of what's in the parentheses with x. So the opposite of positive 3 is negative 3. And then the constant of the equation, but there is no constant, so that's going to be a 0. So my vertex is negative 3, 0. Okay, I need two numbers bigger, so negative 2 and negative 1. And two numbers smaller, negative 4 and negative 5. Okay, so I've got to put a negative 2 in to my equation. So I've got negative and then parentheses negative 2 plus 3 squared. Okay, well, inside the parentheses first because of the order of operations. So 3 take away 2 is 1. And then 1 squared is 1. So that equals negative 1. And because of symmetry, the one above the vertex is also negative 1. Okay, now I'm going to plug in a negative 1. So negative parentheses negative 1 plus 3 squared. Okay, in the parentheses, leave the negative outside alone. 3 take away 1 is 2. So I've got 2 squared. 2 times 2 is 4. So that equals negative 4. Which means this is also negative 4. So now I'm going to graph those points. Okay, negative 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 4, negative 1. 1, 2, 3, 4, 1. Negative 3, 0. 1, 2, 3, 0. Negative 2, negative 1. And negative 1, negative 4. And that's the parabola. Next one. Okay. The very first thing in the equation is a parentheses, so this plus 1 in the parentheses means left 1. And the plus 4 at the end means up 4. So in relation to the apparent function, this graph is going to be left 1, up 4. My vertex is the opposite of what's in the parentheses with x. So the opposite of positive 1 is negative 1, and the constant at the end is 4. So my vertex is negative 1, 4. Negative 1, 4. So two numbers higher is 0 and 1. And then negative 2 and negative 3. Okay, so we have parentheses 0 plus 1 squared plus 4. So 1 squared plus 4 equals 1 plus 4 equals 5. So this is 5, and the one above the vertex is also 5. Okay, the next one is a 1. So parentheses 1 plus 1 squared plus 4. 1 plus 1, I've got 2 squared plus 4. 2 squared is 4. 2 times 2 is 4, plus 4 is 8. And if this one's 8, so is that one. Okay, I'm going to graph that. Okay, I need to make these in increments of 2. Negative 3, 8. So if I'm counting by 2s, negative 3 is here, and then 2, 4, 6, 8 right here. Negative 2, 5, negative 2, and then 2, 4, 5. Negative 1, 4 right here. 0, 5, 2, 4, 5 right here. And 1, 8, 2, 4, 6, 8 right here. Next one. Okay, the negative means it's reflected across x. In the parentheses, the -1 means right one. And then a adding at the end means adding means up one. So it's going to be reflected across x. It's going to be a down, opening down. It's going to be right one and up one from the parent function. Oh, I forgot the 1/2. Sorry about that. Okay, so the 1/2 is a vertical shrink of 1/2. Okay, my vertex is the opposite of what's with x, so the opposite of -1 is +1, and then the constant at the end is 1. So 1, 1 is my vertex. Two numbers higher, so 2 and 3. Two numbers lower, so 0 and -1. Okay, this is my vertex here. So I'm going to take the 2 and plug it into the equation. So -1/2 times 2 minus 1 squared plus 1. That's -1/2. 2 minus 1 is 1 squared plus 1. -1/2. 1 times 1 is 1 plus 1. -1/2 plus 1 equals 1/2. So this is 1/2, and the one above the vertex is also 1/2. Now I'm going to plug the 3 in. Substituting the 3, I'm going to come over here because I just ran out of room. I'm going to do, where's my equation? -1/2 times 3 minus 1 squared plus 1. So that's -1/2 times 2 squared plus 1. -1/2, 2 times 2 is 4 plus 1. Half of 4 is 2. That's -2 plus 1 equals -1. And if that's -1, the one above it is also -1. Okay, so those are the points I'm going to graph. -1, -1, 0, 1/2, 1, 1, 2, 1/2, and 3, -1. Okay, it looks kind of squished because it is a vertical shrink, and because, let me try that again. I just checked the points, so I'm just having problems graphing this. I think it's because the 1/2 here, and -1, -1. Okay, these are the correct points. I'm not sure why my graph's not working out for me. Okay, it kind of goes like that. You can kind of see it's not supposed to be a V, it's supposed to be a curve. But the problem is it's like zoomed out too much. Sorry about that. I did confirm that these are the correct points though. Okay, write an equation of the quadratic functions whose graph has a given vertex and passes through the given point. The first thing I want to do is take the vertex and put it in using the, remember it's the opposite of x, but since you have 0, you're just going to have y equals x squared. There's not going to be any parentheses because there's not a number with the x value. And then whatever the y value is, write it down. So that appears to be the equation, but I want to put the point 1, 0 in. I want to plug 1 in for x and see if I get 0. If I do, that tells me I have the right equation. So 1 squared take away 1. 1 take away 1 equals 0. So I wanted it to be 0, so that means this is the correct equation. Now this one, there is a value for the x on the point, so you have to use parentheses and use opposites for the x value. The opposite of positive 2 is negative 2, and I'm going to square it, and because of this 0, you do not have a constant at the end. Now just like before, I'm going to take the x value and test it against the equation that I just came up with. So 0 minus 2 squared, negative 2 squared. Negative 2 times negative 2 is a positive 4, and that's exactly what we wanted. So this is the equation for that information. Okay, the very next one. There is an x value for the vertex, so you've got to do y equals parentheses x, and then the opposite of the x value. The opposite of negative 1 is positive 1. I'm going to square that, and then the y value just goes at the end of this equation. I'm going to test my 2 to see if this is the point that matches the equation. So 2 plus 1 squared plus 5, that's 3 squared plus 5, 9 plus 5 equals 14, but I wanted a negative 4. So that tells me that this equation will not work, but I do know that this is the vertex. So what I'm going to do next is just go ahead and see if it just reflects. So I'm just going to put a negative in front of the parentheses. Everything else I'm going to leave it like it is, and then I'm going to substitute the 2 in for that. So negative 2 plus 1 squared plus 5, negative 3 squared plus 5, negative 9 plus 5 is negative 4, and that is exactly what I wanted, so this is the equation for that.